been asked to resurrect this tweed Fender Bronco amp from 1996. The Bronco was a solid state 15 watt bedroom / practice amplifier produced by Fender between 1994 and 2001. On the face of it, it looks pretty good. Cosmetics look quite nice, but when we look a little bit closer, things look a little bit grubbier. There's the control panel. All of the original markings have long ago rusted and worn off. And the Fender Bronco was a made in USA amp and in good condition. Examples are fetching, quite reasonable sums these days. This one would not. Let's have a look inside. So my plan is to use the original chassis. There's not a great deal of space inside this cabinet, so I've cut a couple of holes in the original chassis, and I'm going to put my turret board up on spacers. The tubes will poke through those holes, and in a moment I'll show you the transformers that I'm going to use. I've worked out there will be room for this, and of course we'll need to do something with that control panel, the original control panel. It was a 2-channel amp, so there was normal volume, and then there was a drive switch, and so the overdrive channel had its separate volume, and there was gain control, and then a 3-way tone stack for bass, mids and treble. So a lot of knobs on that front panel for such a little amp. My version will just have 2 knobs, which is all you need, just a volume and tone. If you're interested in following this along, stick with me. Well, I'm currently trapped inside my shed by a severe rain depression, but I'll turn that to my advantage by continuing work on my latest project, which is to turn a little very sad solid state Bronco tweed amp into a valve charged monster. One of the problems with doing that is that solid state circuits take up very little space compared to a valve circuit, which is really the whole point of historically going from valve to solid state. But we're going back the other way. So I'm using the chassis from the Bronco, and I've got a turret board here with the 2 valve sockets. I'm setting that up above the chassis, and I've just drilled guide holes for the cutout for the power transformer. Now, because of the lack of space inside the cabinet, I've had to search for the smallest power transformer that would deliver the current and the voltages that I require. And I've gone to a Hammond 291 ACX, which, as you can see, is quite diminutive. But this normally is used to drive a Fender Super Champ XD, which is a hybrid amp. It has valve output tubes, but the rest of it is transistorized with some digital effects. So it has a huge number of different secondaries for 9 volts, I think 35 volts, and a bunch of other things, most of which will be cut off and remain unused. But it has a low profile and will fit into the allocated space. So that's the next step, is to get that power transformer onto the chassis. Ta-da! Power transformer is in. I'm still waiting for the output transformer to arrive, which I've ordered. Next step, I believe, will be to populate the circuit board, and I'll give you a look at the schematic that I'm going to be using. So here's the chassis all wired up. The only thing that's missing is the output transformer, but it's going to be hiding underneath the chassis with just a couple of leads on top. So it's all going to look pretty much like this in the end. It does surprise me how a simple 5-watt single-ended amp can take so long to put together. When you're working from a kit or a schematic that you've used many times, it can be done fairly quickly, but this is even with planning, this is a bit of a make it up as you go along, and quite often I ran into situations where I'm thinking, okay, where am I going to put that component? And oh yes, I need to drill another hole somewhere. But it's getting very close to the point where I can plug this in and try it out. The circuit I'm using for this rebuild of the solid state Fender Bronco amp is based on a circuit that I used for a build 4 years ago, which combined features of the Fender Champ and the Kalamazoo #1, both favourite small amplifiers used by harmonica players. I called this the Kalama Champ because it was a combination of features of the two amps. A bit of a clumsy name, but anyway, it will be familiar to many of you who know these circuits. So there's a 12AX7 preamp with a tone and volume control placed in between the two triodes of that valve, and the output is with a 6V6. Now, the one that I built back then had a 6X5 rectifier. This one is using a solid state bridge rectifier. So the value of the filter capacitors, in particular the first one, has been increased accordingly. So instead of a 16 microfarad first filter cap, that's going to be 47, and the others will be 22 microfarads. Probably the main area where this circuit differs from others, particularly the Fender, the 5F1 Champ, the favourite, is that there is no bypass cap on either triode of the 12AX7, and this reduces the gain of the preamp, and this works better for harmonica players because the microphones have fairly substantial output, and they can overload the input of the amp if there is too much gain. Another change is in the caps, the coupling caps. The value of those has been set to allow a little bit more bass to pass through. Now, the original build that this circuit was drawn for used a recycled vintage power transformer, which only put 215 volts on the 6V6 plate. But it produced a glorious tone. It was a really lovely sounding amp. The power transformer I'm using in the current build will be putting out substantially more, well over 300 volts on the plate of the 6V6, and that will make a difference to the sound. We just have to wait and see how it turns out. Here's my rough layout diagram that I'm using for the Bronco refit, and with this there's the influence of yet another favourite single-ended 5-watt amp that's used by both guitarists and harmonica players, and that's the Epiphone Blues Junior. The turret board that I'm using for this was actually designed as an upgrade for the printed circuit board in the Epiphone Valve Junior. And so the instead of the valve sockets being attached to the metal chassis, the valve sockets are actually part of the board, and the wiring is it looks a little bit haphazard. It's really like the old point-to-point wiring in the pre-war valve amps, but it actually means that the wiring is as short as possible, and hopefully that means that there is less hum. We'll see. As far as grounding, which is something that has a lot of effect on any hum that there may be in the amp, I'm using a bus, and I was going to use my regular practice of a separate ground for the power supply components, and then the preamp part of the circuit has its own ground, but I'm actually using more of a star ground system with this, and I'm using a bus which has all of the earths connected to it, and it is grounded to the chassis at one point only, and I'm hoping that that will give us a quiet amp. Well, we shall see. Well, I've just had a wake-up call with the build of this little amp, and the message is, don't get too cocky. You build a few amps and they work well and you think you know it all, and then you start making basic mistakes. So I got to the point where I turned this on, wasn't working, nothing was going right, and switched off and had a good look at the circuit, and two things. First of all, if you look back at the early parts of this video and look closely, you'll find that the filter caps are put in back to front. Yes, absolute beginner mistake. So fix that up. Fortunately, I was only putting very low voltages through the amp to see if a signal was coming through. So, okay, filter caps put in the right way around. The other mistake that I made is I was waiting for an output transformer to arrive, and got impatient, and I decided to put in a donor output transformer from an old valve radio. And looking at the colours of the wires, and the lesson here is don't be fooled by the colour of the wires, I thought that these were the wires, the primary, and this would have been the secondary wires going to the speaker. I think green and black, that's usually 8 ohm tap and ground. Well, it took me quite a while to figure out that no, that was completely arse about, and ignore the colour coding, the wiring was around the wrong way. Ah well. In the meantime, the output transformer did arrive, and I've drilled more holes in the chassis to take account of that. Anyway, this time I made sure that I have the primaries and the secondaries in the right place, and I'm just about to solder that up, and we'll give it another go. Now, I mentioned earlier that I had to choose for this build a power transformer with a fairly low profile in order to fit the small space in the cabinet. Now, one of the consequences of that is that I have a power transformer with the B plus secondary having no center tap. So I've had to use a bridge rectifier. That's the 4 diodes that you see here, and consequently the voltage on the plate of the 6V6 is higher than I would like. It's up around 400 volts. Now, with modern 6V6s, that's tolerable, but it's going to give me an amplifier that is loud and clean and doesn't break up very much, which would be fine for a guitar player, but this amplifier is going to be for a harmonica player. So I want less volts on the plate of the 6V6 so that we get a little bit more breakup. Now, when I say less or fewer volts, I mean I want to drop it down to closer to 300, 350 volts. I need a drop of about 50 volts. And one way of doing that is to use a power resistor. So the little gold thing you see there is an aluminium clad 25 watt 1.5K resistor. And so basically I'm just running a wire from the B plus through that resistor to a ground on the chassis, and we're just losing that 50 volts. It has to go somewhere, and it ends up as dissipated heat. Now, what I've found is that this works. I get my 50 volt drop through that resistor, but the amount of heat generated is actually melting the solder on the joins, and it gets very, very hot very quickly. So that's clearly not a good solution. So we move to plan B. So plan B is a string of zener diodes. Each one of these little fellas will drop the voltage by about 10 volts, and each one is rated at 5 watts. So instead of having one big fella resistor dropping voltage and creating a lot of heat, we've got a series of smaller devices and hopefully producing less heat. So this goes in between the rectifier and the first filter capacitor, and as you can see, all of these diodes are facing the wrong way. So that's how these zener diodes work, and we'll see what the result is. Okay, the amp has been running for about 10 minutes, and the chassis is barely warm to touch below the string of zener diodes. So I'm just checking now with my multimeter to see what sort of temperature is being generated. So that's 56, 57 degrees centigrade. It seems to be climbing at the moment, but it just wanders around, but is not getting much over about 60 degrees. So I call that a success. Well, as you can see, the amp is working. I've fed some music from an old iPhone into the input, and the chassis connected to the workshop speaker. I had to make some changes, first of all, to bias the output tube correctly. Finally, by trial and error, arrived at the right cathode resistor. And I've got this biased for vintage 6v6 tubes rated at 12 watts, and I've got this biased at just under 100% dissipation. But if you put a newer, for example a JJ 6v6 rated at 14 watts in here, it'll putt along quite comfortably. Now, just when I thought I had all the voltage problems sorted out, you remember I've put that string of reverse zener diodes to drop the B+. I found that I was blowing pilot lights, and when I checked the filament winding on the power transformer, it was putting out not 6.3 volts but 7.1 volts, which is outside the 10% tolerance. And so did a bit of googling, and once again solid state devices have come to my aid. And one of the wires from the transformer providing the filament voltage, I connected that to, whoops, sorry, I'm on the wrong socket. I connected that to an unused pin on the 6v6, and if I zoom in you can probably see I've got a pair of 1N4007 diodes. They're connected in parallel but pointed in opposite directions. So this one has the stripe pointing at this end, the other one has the stripe pointing at the other end, and that's because we've got AC current flowing through the wire. We only need to do this to one leg of the heater winding, and it has dropped the supply voltage down to a lovely 6.3 volts. So I'm no longer blowing pilot bulbs, and I know that the tubes are going to run their normal lifespan because there's not too much voltage on the heaters. So another unexpected problem cropping up in this build, but we are getting towards the end, and I'm just going to get it into the cabinet for the final test. Well, in the end, this simple conversion of a 1996 Fender Bronco solid state amp to a valve amp has caused me quite a few headaches and rethinks, and I thought it was going to be an easy ride, but never mind, we got there in the end. And since I last spoke, I've made a few more minor changes. I've changed the tone control to a simple treble cut. I did add a bypass cap to the first triode's cathode to get a little bit more grunt, and I also increased the value of the coupling cap to the 6v6 to get a little bit more bottom end. All of those changes will be on the final circuit, which I will add to the comments for anybody who's interested. And now on to a few demonstrations.
stop breaking down. That stuff I got will bust your brains out, baby, make you lose your mind.